Hi students, MCQ number 14. At what temperature is the root mean square speed of an atom in argon gas cylinder equal to the RMS speed of a helium gas atom which is at minus 20 degrees Celsius. So the atomic mass of argon and helium is given. It is a very simple question. You will have to read twice or thrice till you understand that question. See, helium gas is maintained at a temperature minus 20 degrees Celsius. So corresponding to this minus 20 degrees Celsius, what will be the RMS speed of helium? We have to find out. And that is also equal to the RMS speed of argon gas which is maintained at some other temperature. What is that temperature is the question. Have you understood? So, we will take first argon. Okay. So, for argon, what is the given? Atomic mass. So, here the molar mass M1 is equal to 39.9 U. And it is maintained at a temperature. What temperature we don't know, we have to find out. And for helium, the molar mass is equal to 4 U and it is maintained at a temperature T2 that is equal to minus 20 degrees Celsius. If I add 273 means it will be expressed in Kelvin. So 273 minus 20 is 253 Kelvin. Very simple. Now the RMS velocity Vrms for the first gas. So this is equal to square root of 3R into T1 divided by M1. And Vrms for the second gas, that is helium. Okay, for the second gas helium. So this must be equal to square root of 3RT2 divided by M2. So the RMS velocity of the first gas, that is argon. We have to substitute M1 in the denominator and T1 in the numerator, and we have to find out T1 only. So like that M2 and T2 must be substituted in the Vrms for the second gas. So now I will take Vrms for the first gas is equal to Vrms of the second gas. Both are equal. So I will take Vrms of the first gas divided by Vrms of the second gas, and this must be equal to 3RT1 by M1. So this is equal to 3RT1 divided by M1 into M2 divided by 3RT2. Okay. Now the left hand side ratio, the ratio is equal to 1 by 1. So 1 is equal to, because Vrms of both the gases are equal, they are given, is it not? Therefore the left hand side ratio must be equal to 1. Right hand side is 3 and R get cancelled. So we get this is T1 by T2, T1 by T2 into M2 by M1. Now if I will square on both sides, squaring, so 1 square, that also is equal to what? 1 only. The right hand side, this is a T1 by T2 into M2 by M1. Okay. So what is required here? T1 has to be determined. So T1. So I can shift this to the left hand side. Therefore T1 must be equal to M1 by M2 into T2. Okay. Into T2. So I am going to substitute now. What is M1? M1 is 39.9. So 39.9 multiplied by T2. T2 is 253. So 253 Kelvin divided by 4. So now we have to calculate roughly if you take means this can be taken as 40 by 4 is what, 10 multiplied by this is what, 2530 Kelvin, understand, or 2.53 into 10 power 3 Kelvin, roughly I am saying. Okay, since it is given in some odd values of the numbers, we have to go for the calculation check. So now 39.9 multiplied by 273 is equal to 10892. So 10892.7 divided by 4. So this has to be divided by 4. What we get is 39.9 multiplied by 253 is equal to, so this is coming as different number, so I will change this, 1094.7 is coming. Okay, so this has to be divided, okay, this has to be divided by 4. So this is coming as 2523 roughly, okay, Kelvin. So this can be written as what, 2.52 into 10 power 3 Kelvin. The last digit can be eliminated less than 5. So I am getting as what, 2.52 into 10 to the power of 3 Kelvin. So this is a 2.52 into 10 power 3 Kelvin. So option B must be the correct answer. Therefore, option B is the correct answer. So this is very simple problem only. Okay, just the formula, if you remember, means we can substitute and find out the correct answer. I hope you must have understood well. Fine.